Jai Hind to all. Myself Yogendra Prajapati, Assistant Professor at Ajay Kumarkar Engineering College, Kasiabad. Today I am going to teach a very important topic of the compiler design, that is known as the SLR parsing. SLR parsing is a type of the bottom-up parsing, and this is the subsection of the LR0 parsing. SLR parsing, this type of the question is also asked in the university examination and GATE examination and other competitive examination like PSU and others. Now, in SLR parsing, what different topic we are going to discuss, that is known as the basic architecture of the SLR parsing, and there are the some step how the SLR parsing are designed of any given context-free grammar. Then for the better understanding, we take a simple example how to construct the SLR parsing table and SLR syntax tree and go to action table. For the better understanding, we take 3 example, 1, 2 and 3. Now let's start what are the SLR 0 parsing basic architecture. Now in SLR basic parsing architecture, there is the one input. The input string are stored. Then with the help of the SLR parsing algorithm, we design the SLR parsing table. In SLR parsing table, basically divided into the 2 parts, action and goto. With the help of the algorithm, table and stack, we design the final outcome of the SLR parsing algorithm. So these are the basic architecture of the SLR parsing concept. In action part, there is a 2 type of the data are exits. First one is the shift and second one is the reduce. And in go to action, we fill only the state of the finite automata. Now these are the various steps involved in SLR parsing are that is very simple. We are the few steps when we are going to SLR parsing of any given context-free grammar. First, write a context-free grammar and check the input string. Write a context-free grammar and then check the input string. That is the first step of the SLR parsing algorithm. Now, the second one is check for the ambiguity of the grammar. If grammar is ambiguity, then SLR parsing is not possible. So, in second step, we check the if grammar is ambiguous, then we are not. Grammar is unambiguous, then we are go for the solution for the SLR parsing algorithm. Now, if grammar is unambiguous, then we start the procedure. Then third step, add the augmented grammar. If grammar is unambiguous, then we add the one extra production rule in a given context-free grammar. This procedure is known as the augmented grammar. This step is main important of the SLR parsing algorithm or any bottom-up parsing algorithm like LR parsing algorithm or CLR parsing algorithm or LLR parsing algorithm. In previous lecture, I explained the LR parsing algorithm, in which I also create the canonical collection of LR item, SLR item. Now, this is the main important concept, this is the main important procedure for the designing the SR parsing table. If this concept are designed, then draw the DFA of the canonical collection item of the SLR parsing. Then construct the SLR parsing table. If we draw the DFA of a given context-free grammar, then construct the SLR parsing table. In SLR parsing table, action and go to are contain, and in action part, shift and reduce, and in go to part only state are contain. Now, based on the information of the with table, with the help of the stack and parsing algorithm, we generate the final outcome. This line, with the help of the algorithm, parsing table and stack, we generate the final outcome. This is the procedure for the SLR parsing algorithm. Now we take the very simple example. We take this one. First we check this grammar is ambiguity or not. So in automata lectures, I explain how to check any grammar is ambiguous or unambiguous. We derivate the LMD and RMD. If more than one LMD are generated of any given context-free grammar, then that grammar is ambiguous. If more than one LMD or more than one RMD. So for this context-free grammar, only one LMD are generated, so that we can say that this grammar is unambiguous. Now, what is the second? The first step, we write a context-free grammar. Here we write the context-free grammar. Now the second step, check the ambiguity of the grammar. Now we check the ambiguity of grammar. The grammar is unambiguous. Okay. Now the third step, add the augmented grammar. So what is the procedure to add the augmented grammar? That is very simple. S tends to S dash and S dash tends to E and yes. Sorry. What is the add for the augmented grammar? We simply add one extra production rule, that is S dash tends to S and S tends to E, and this extra production we are added into the given context free grammar. Now remaining production rule as it is same, and T tends to T multiply by the F and F, and F tends to ID. I think another one things, if grammar is a left recursion, then for any parsing algorithm, first we follow the remove the left recursion. So I think in this production have a left recursion, and also in this production have contain the left recursion. Then we remove the left recursion rule. Now what is the removing the left recursion? A tends to A alpha and beta. Then what is the procedure for the removing the left recursion? That is A tends to beta A dash and A dash tends to alpha A dash. This is the procedure by which we remove the left recursion of any given context free grammar. So we apply this method by which we remove the left recursion for this given context free grammar. Now if we apply, now this is the alpha, now this is the beta for this production. Now if we remove the left recursion for this production, then E tends to beta T A dash, sorry, E dash yes, and E dash tends to alpha. Alpha means plus T and E dash. Now when we remove the left recursion into this production rule, then we find these two production rule. Without removing the left recursion, we cannot further proceed for the SLR parsing algorithm. Similarly, we remove the left recursion for this production rule. Now this one is alpha and this one is the beta. Now what is the T tends to beta, F T dash, and T dash tends to star, this is the beta, and T dash. This is the we remove these 2 production and add this 4 production. Then this is the for 1, 2, 1, 2, and 3, 4, 5, 6, 7 production rule are added, by which we perform the SLR parsing algorithm. Now we remove this one, no need for this one. Now we write the no need of this grammar and no need of this grammar, because in this both production contain the left recursion. Then we remove the left recursion and find the 4 production. We are added these 4 production into this context free grammar. Now what is the original grammar? Now E tends to TE dash and E dash tends to plus TE dash. Now no need and for this also, and F tends to ID, we remember that, and add this here, T tends to F T dash and T dash tends to star F T dash and F tends to ID. So now this is your final context free grammar, in which we perform the what for this production, we perform the create a conical collection of SLR item. So for this production, we create the conical item of the SLR production. Now for the SLR production, we put simply dot 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 of every production rule starting to the right side of the production, and create the if we put the dot for every production on the right side of this, then this is and create the DFA of this context free grammar. When we are creating the DFA of this context free grammar, then dot shift to the right side. When dot shift to the right side, then this terminal or non-terminal work as an input of the deterministic finite automata. Similarly, we apply when dot shift to the right side, then this terminal or non-terminal work as the input of the deterministic finite automata. Now here yes is an input and yes tends to yes dot. When dot enter to the last of the production rule, then that production rule is known as the final state of the finite automata. Simply E and yes tend to yes tend to E dot. This is also known as your final state, and we apply the same procedure. T anywhere T, no, now T, now E tends to T E dash, and we explore when dot comes any non-terminal, it indicates that we explore that non-terminal production rule all. It means dot comes to the E dash, then we write the production rule of the E dash. Now, where the production rule of E dash? This one, E dash tends to dot plus T E dash. Now, this step has been complete. Now, this production has been explained. Now, this production, here is a plus and E dash tends to plus T E dash. Similarly, we explore the production rule of the T. So, where is the production rule of the T? Now, here is a T dash tends to dot F and T dash. Again, we explore the production of the F. Now, F tends to ID. Now, this step are complete. Now, this production has been explored. Remaining this production we are going to explore, and this production we are going to explore. Now, when we explore this production, now T dash tends to star F T dash. Similarly, we write the production of the F, that is F tends to dot ID. Now, this is also explore, and we explore last one, that is F tends to ID dot, and here is ID. Now, this is the first step of the conical element, and this step is final step, this step is final step. Then we need to explore this state, we need to explore this state, we need to explore this state, and this state is also a final step. Any production, when dot enter into the last of the production, then that production is known as the final step. Now, we explore this production. Now, here what is the E dash? E tends to T E dash. Now, this is your final state because dot enter comes on the last, and final state. This is the final state. When explore this one, and what is the that is the plus, and yes, E dash tends to plus T E dash. We need to explore the production rule of the T. And what is the production rule of the T? Only one production are available, that is T tends to dot F T dash, and we need to the production of the F because F comes to the right side. Now, check. I think when we explore this production, then we find the this production rule. So, no need to write this production extra. We simply for the plus, no need to write to this one because this one and this one state are same. Now, this one is a complete. We explore this one and explore this one. Only two state are remaining. Now, when this one, now this is the T, E dash tends to T dot E dash. What is the next step? We should explore the production rule of the E dash. Now, what is the production rule of the E dash? Now, that is very simple. E dash tends to plus T E dash. No need to further explore for this production. Now this is over. Now we need to explore second this one. Now what is this? And I think T dash. What is the production rule of the T dash? Star. I think different one, different state are we find where the T dash. No. We check the another production, that is F. T tends to F dot T dash. Then what is the concept are said? We explore the production rule of the T dash. And where this production rule? This is T dash tends to dot star F T dash. And what is the need to the further exploration? No need to require for the further exploration. Okay. Now when we explore this production, we reached for this year this one. Now this one is a complete, and this one need to explore. And when we explore this production, we read from this one. Here is ID. And yes, we need to explore T dash, and we explore I think this one that is known as the F. Yes, how many remaining state are come? We need to explore this one and this one. So we explore this one. We simply E dash, and E dash tends to T E dash. Now this is your final state. When we explore this one plus T and T production, this one and this one. Now this one, this is the T. We need to explore this one. Now here that is T dash, and T tends to F T dash and this one. Okay, this one has been explored, and F. This one is your final state, and T dash. And here when we are explore this one, and here it is a F, and F tends to ID. Yes, we need to explore this one, and that is F, and T dash tends to star F T dash. And we need to explore the production rule of the F. The production of rule of the F, it means F tends to ID. Now this one is your final state. This one is your final state, and only this one state are remaining. With the help of this is the complete conical collection item of the SLR parsing algorithm. Now this lecture is too much time, so that for the next part of this lecture, that is the SLR parsing table, we conclude into the next lecture, and final outcome we'll discuss into the next lecture. Thank you.